Good morning, dear students. Now, in today's video, we are going to learn how to change the order of integration. And in this, we are going to learn one very important concept. Now, before that, just in 2 minutes, I will recollect what we done. We had done in previous video. I taught you how to evaluate this where R is given to you. We have integrand, that is function of x and y. We are given the region. I give you all these steps. Just if possible, keep them in front of you and let's revise. The steps which I gave you for this are: first step I told you, sketch the curves. Sketch first curve, write the equation. Sketch second curve, write the equation, find point of intersection, then find the required region. Let me have one simple example. Suppose this is our region. Just recollect the steps again. The very important step now. We take vertical strip P, Q, find y at P, y at Q, move it from left to right. Here you get limits of y, by moving you get limits of x, and then you can evaluate. Another method I told you, take horizontal strip PQ, find x at P, x at Q, move it from bottom to top. You will get limits of y by moving, and this gives you limits of x. I hope you remember all this, because same we have to apply here in change of order. When we took vertical strip, understand this part, when we took vertical strip, we got inner limits of y which were in terms of x, and we got outer limits are of x which are the constant. So here we have to integrate first with respect to y, and exactly opposite way, when you take horizontal strip, there we got inner limits are of x which are in terms of y, and outer limits are of y which were the constants. So you know very well, here we need to integrate first with respect to x. So you will understand what is meaning of change of order. If your problem is of this type and you are asked change the order, that means here we are integrating first with respect to x. You have to change the limits in such a way the limits are now of this form. Means inner are of y and outer are of x which are constant. So here we will integrate first with respect to y, and here we will integrate first with respect to x. So understand meaning of change of order. If you are given this type, you have to convert to this. If you are given this type, you have to convert to this. The procedure is more or less similar. That's why I just revised this. Vertical strip, y at P, y at Q, move from left to right. One method which gives us with respect to y first and then x. Horizontal strip, x at P, x at Q, move it from bottom to top, and it is of this type. You get limits of x in terms of y. So first integrate with respect to x and then y. This is again and again I am telling you, because same thing we are going to apply over here. So this problem's change of order, where you will apply it. First of all, if you are appearing for any exam, you may have problem. Change the order of integration, then obviously you need to change. And if you are just solving some integration, but if you are not happy with given order, means if you have inner limits are of y, outer of x, so you have to integrate first with respect to y. And you can see with respect to y, it's very tedious to integrate. Whereas with respect to x, it is very easy to integrate. Say a simple example I had written. I am not saying it's impossible. You know you can have derivative here. It is f dash x upon root fx, etc. Still you can see with respect to x, it's very easy. But suppose the given order is y first and then x. But you want x first and then y. So even if it is not compulsory, you may swipe. How to swipe? Not just swipe. You have to change the order, and let's see how to change the order. So I will just start with a problem. Our problem is change the order of integration. And our first problem is y is from 0 to 2, x is from y to 2 plus 4 minus 2y under root fxy dx dy. Change the order of integration. So before you have to change the order, see what is the given order. Given order says here, first you have to integrate with respect to x and then y. So understand this, the given condition they have taken horizontal straight. We want now first y and then x. So clearly you know very well we have to take vertical straight. Rest procedure is same. Let's do this problem. Now here, first thing, similar steps. What I gave you steps over there. First step I gave you sketch the curves. Here which curves you have to sketch? Our curves are y equal to 0, y equal to 2, then x equal to y and x equal to 2 plus root 4 minus 2y. Now one of these four curves will be always like this, where you need to have bit of simplification. This you can make out immediately. This is x-axis, then y equal to 2 is a straight line parallel to x-axis. X equal to y, everyone knows it is a straight line passing through origin. What is this? I have x is y and x is 2 plus this. If you want to know what is this, it's not very difficult to make out in the first look also. But even if you can't, let's simplify. I will have x minus 2 is root of 4 minus 2y. So I will square from both the sides. And here I will take minus 2 common. I am getting y minus 2. What I had done now you can recollect. What are our parabolas? We have parabolas. X square is 4ay, x square is minus 4ay, y square is 4ax and y square is minus 4ax. So I have x minus 2 as capital X and y minus 2 as capital Y. See, same in this leg. Means what is my capital X? It is x minus 2 and capital Y is y minus 2. So this becomes of the type x square equal to minus 2y. Means it is of this type. And this type of parabola, again all of you know, it is this way. These were the standard parabolas. Like you had here, origin, vertex was origin. Here, what is the vertex? It will be 2, 2. This is what standard match already done. This is shift of origin. Where we have shifted origin? 2, 2. X is x minus h, y is y minus k. And here vertex is new origin, that is 2, 2. So it's clearly this is parabola, downwards parabola. Vertex is this 2, 2. So it is something this kind of parabola. That is the first thing you have to make out. And now we will go for proper sketch. Let's sketch it now. So you got the idea of this curve. Rest all we know. Now let's sketch it properly. So first I will sketch this. We found out it's a parabola, downwards parabola. Vertex is 2, 2. Let's have somewhere 2, 2 here. Now very important question. This parabola, you know this is the vertex. Is it this type? Is it this type? Or it's passing through origin. When your origin is there, you must be careful whether origin lies on the curve or it doesn't lie. And you can check very well. You know how to check. Put here x equal to 0, y equal to 0, and you can say the equation is satisfied. LHS equal to RHS. So this is a parabola where origin means 0, 0 lies on the parabola. It's a parabola passing through origin. So let's sketch this. It is something of this type. So again we'll follow the same steps. Sketch the curve and immediately write the equation. Our equation is x is 2 plus root of 4 minus 2y. This is the point 2, comma 2. This is origin. What is this point? X-axis, y is 0. So if you put y is 0 here, then what you are going to get? This is 4, comma 0. This anyone can do. Now secondly, we have x equal to y. What is x equal to y? It is a line passing through origin. Now sketch properly. I am telling you again and again, with respect to first curve, you need to check. Okay, I will just tell you one simple thing where maximum students make mistake. And that's why I have given you some steps. This is a wrong sketch. But many students make it, and how you will make out in the exam or while solving, how you will make out. Whether you had done any mistake. If curve is wrong, everything is gone. That's why I gave you the next step. Sketch the curve and immediately find the point of intersection. When you find point of intersection of this line and this curve, you will come to know the point of intersection is 2. It's very easy for you people. X equal to y, you can put it in this curve. What is the equation of this curve? X equal to this. Put x equal to y and you can simplify. You will get a point is 2, 2, and then you will realize your sketch is wrong. And very common mistakes we observe in exam, that's what I am telling you. Immediately find point of intersection. So even if you make mistake, immediately you can get it. So what you observed is, this is the line passing through this point 2, 2. And this is our second curve, which I have sketched here. And immediately we need to write the equation x equal to y. Then we have y equal to 0. Y equal to 0, that is our x-axis. Y equal to 2 is a line passing through 2. Y equal to 2, so it is parallel to x-axis, and this is our line y equal to 2. We have sketched all the curves. We have found point of intersections. Everything is clear. Now the next very important step. I told you in the previous video that next step is get the region. And I said there this step is very important because in some problems you can see there are 2 or more regions. And don't get confused here. So I said here we are going to learn very important concept. One point, as I said, how I sketched it. This is some uncommon curve, I will say. Secondly, I said this is the second kind of mistake students make. So find the point of intersection immediately. Third is region. Without thinking, students will see this is one region, this is one region. So many times students may take this blindly. Some students may take this blindly. Of course, it's wrong way. How to select the region? Listen now. Limits of y from 0 to 2. Lower is 2, lower is 0, upper is 2. Meaning is, it is above y equal to 0 and it is below x equal to 2. See very well. Above y equal to 0 and below y equal to 2. So it is this region. If the same problem, if I write 2 to 0, 2 to 0, what is the meaning of that? This will be below y equal to 0 and above y equal to 2. So there is no common region. So I said understand this part to find out the region. Okay, why it's okay? Important part, and the part where students may make mistake is this. This all of you can understand is above y equal to 0, below y equal to 2. So it is in between these two lines. Now for x, see again, its lower limit is x equal to y and upper limit is this parabola. Understand this point very well. X increases in this direction. So this is lower limit, means this is left hand side limit. It is to the right of this line and to the left of this parabola. Once again I am telling you, if you have lower limit of x is f1y, upper limit is f2y, whatever is f1y, our region is to the left of f1y and to the right of f2y. Lower limit, x increases in this direction. Upper limit, maximum limit, and x decreases in this direction. So it is less than this maximum limit, greater than this minimum limit. So it is to the right of lower limit and to the left of upper limit. This is very important thing you have to understand. So here see properly what these limits tell you. It is to the right of this line and to the left of this parabola. To the right of this line, can you see this? To the right of this line and to the left of this parabola, above this line and below this line, and you can see this is the required region. Now I will tell you, if you have this lower limit as parabola and upper limit as line, suppose lower limit as parabola means it is to the right of parabola and left of the line. In that case, can you see this would have been the region? Understand this part. If this parabola is the lower limit, what I said? To the right of lower limit, so it would have been to the right of parabola and to the left of this straight line. So this would have been the region. So see the limits properly and get the region. So we got the region successfully. Just have a look for 1 or 2 seconds. And now it is the time to take the strip. Now to take the strip, whether it's vertical or horizontal, again look at this. What is the given order? Same thing I am telling you. Given order tells us first with respect to x, because inner limits are of x. We want to change the order. Is what we want? We want inner limits must be of y. First we have to integrate with respect to y. And we can integrate first with respect to y if you take vertical strip. So first point is clear, we need to take vertical strip. Now, we have one more new and very important concept I am going to tell you. In last video, whatever problem we had, say it was something of this type. This was our region. And when we took the strip, we have to move it from left to right. I told you throughout the region, P lies on the same curve. Throughout the region, Q also lies on the same curve. So we found the limit. But here, very important, another concept. I just introduced that in previous video, what to do in such case. That when you take vertical strip, understand this, if my PQ is here, in this case, P is on this curve and Q is on this curve. But throughout the region, anywhere you have to take the strip. So now, if one takes strip over here, can you see now P lies on same curve, but Q lies on different curve. So in such cases, this is the new concept and important concept. You can see here, Q lies on 2 different curves. So this entire region, we are going to divide in 2 parts. This I will call as R1. And this I will call as R2, and it's as good as 2 problems. Nothing else. Rest concept is same. I have divided in 2 regions. Immediately I have to find this point. It is 2, 0, and it is just like when you had an integration, say 0 to 10 you are integrating x square dx. You know this is 0 to 5 plus 5 to 10. You know it. What I have done in integration of one variable. Same way I have here now. This integration over this entire region R is same as now integration over R1 plus integration over R2, and so I have R is this integration fx dx over R1 plus integration fx dx over R2. Sorry, it's not fx, fxy. I'm so sorry, dx dy, fxy, dx dy, and it's as good as 2 problems. Let's evaluate one by one. So the first one, follow the same procedure. What we are doing? We are finding y at P and y at Q. What is y at P? Is 0, y at Q. Q lies on this curve. What is the equation of this curve? With x equal to y. This is the line x equal to y. Yeah, I have written over here. So y at this point is x. So y at Q is x. So limits of y are from 0 to x. Move the strip from left to right. Leftmost, here x is 0. When I bring it here x is 2. And so I have x is from 0 to 2. And exactly same way, second one. Now here I will have say p dash, q dash. Same procedure. Come on now, you can think over it. What is y dash? Y at p dash. Again it is 0 and y at q dash. Look at this now. You need to simplify for y. You can see here x minus 2 whole square is 4 minus 2y. So what will be your y? Y will be 4 minus x minus 2 whole square upon 2. Just as we want to find what is y at this point. Q dash lies on this curve. We found y is this. So my upper limit is 4 minus x minus 2 whole square upon 2. And again move the step from left to right. Leftmost x is 2. This is 4. So I have x is from 2 to 4 fxy dx dy. And this is what we had done is we have changed the order of integration. If the question is change the order and hence evaluate, means you need to evaluate, but here it is just change the order, we are not given what is that. If I give you here say x square y something, then we need to simplify further. It is just change the order, and this is the way you can change the order. Have a look just for 1 or 2 minutes and I will be back. So I hope you understood this change of order. So just in 1 minute I will tell you change of order means whatever are these curves given, sketch them, write the equation, find the point of intersection so you will not make any mistake, and then while finding the region keep in mind for y it is above this curve and below this curve. For x it is to the right of this curve and to the left of this curve, and get the region, which is very important step. Now changing the order means you have to see you want y or x. You want first with if y, then vertical step. If you want first with x, then it is horizontal step. Track the steps. If there are 2 different regions, maybe 3 regions, divided accordingly. It's as good as 2 or 3 different small problems, nothing else. Repeat the procedure, you get it, and that is change of order. That's it. So I hope you understood. In our next video, we will see how to evaluate when the equations are in polar form. Thank you very much.